Good morning, good morning. Hopefully, we'll be able to stream today without problems. Sorry for the late start, just had to make sure of a couple of things. So let's take a look at where we at. Let me also just check. Yeah, this time around we have internet. Okay, so let's see where we're at. We have this when we run around here on our snow, and we want to offset the white parts here, or the highlighted parts, upwards a bit. But we want to use some transform function. Make it into a little bit of a hill here. And that's what we're working on. I don't know if we have one that currently works. Yeah, we don't displace right now, but do we use... Jesus, this looks really good for the trail, doesn't it? Yeah. Okay, but that's not really what we want to see. I want to see... I want this one to go from extremely highlighted here, not highlighted here. We want it to peak around here, I would say. Hmm. Wondering. We're gonna do this. I would like to identify exactly what values we have here. I'm wondering if... Let's take a look. If it's bigger than 0.5, is that really what we want? Yeah, okay, yeah. Height effect threshold. So if we lower this one, we get more like this. If we heighten it, we get more like this. Okay. One sec. Yeah, so the problem is just about finding the right function. Fabric sent me a video which had some pretty good ones I want to take a look at eventually, but I don't think we will have time to do it today because I'm going to have to alter it a bit. But basically, all we want to find is... we want to find a curve that takes us from... What is it? Something like this, I reckon, to something like this. The more controllable, the better for this one. So pretty much we want to take this y value and put it into this one. So what do we have? F of x. I'm gonna do g of x, but we really want to call g y. And it's also important to keep in mind that this one goes from... Now we actually have... Might be like this. But it goes from a constant we choose here up to 1, I think. Actually, that's not true. It goes from 0 to a constant we choose. Like this one needs to be highly customizable. But my question is, I wonder if... Can I set this as 1? That would help a tiny bit. Good morning, Harukanan. 1 sec, we should have... Can't we take a look at something like this? What do we have? We can limit it to 0 and 1 after the fact. X minus 3 minus 2. Okay, just do something with this. This is gonna be the value we send in. We can... I don't think we want to... we want to offset it here, or do we? No, I don't think so. Or actually, we do. Or we might skip this one and then just normalize it between 0 and 1 eventually. And maybe we can just do this. With a minus in front. So if we were to do... displays up multiplier. You do amplitude. Let's assume that this one is between 0 and 1. I'm pretty sure we can add that constraint if we haven't already. Where do we have it? Yeah, it's between 0 and 1, so that's good. So then I wonder why... Then we do plus... displays upward breakpoint. So what do we have here? Displays multiplier. Sum to the power of 2. And then negative. We should be getting this. Ish. So I wonder... We could also do... Let's wait with this one. Minus... displays upward max distance, then we'll be getting this one now. I don't think... Maybe we can wait with that one. So if 0 here, we get this to the power of 2 as our maximum. Is this what we want? Really? Is that what I'm seeing? Mm-hmm. And then I just want to I want to see what we get from this. So let's do and displace up multipliers equal to inverse slurp. Good morning, Calvino. We don't have anything just yet. That's a little bit weird, I would say. Upwards breakpoint 0. Does that make sense? It is. Yeah, it does. If we have 0 here, we get this one to the power of 2. Then we do negative. Then we want to heighten it a bit. We can choose our Y. So what we're doing is breakpoint. And then we take the negative of it. So we get this one right. And then we want to move it up. This is going to be one big improvement part. Hopefully I can get some information, and because we could do, like, best case scenario, we would like it to look like that, everything. Now we're just gonna get a little bit of a bump, but I guess that's okay for now. Just want to see if we can get this bump. So then if we move up this curve, is that how we want to do it? Can't we just move it up by 1 and then saturate it? I wonder. I guess we could move it up by this one. Let me just double check if this is exactly what we want. Minus, minus. Plus, plus, plus. So if we would do this, and then we skip this one and we just do place up multipliers equal to saturate. But we would probably like to do negative here and put all of this around like that. Not that it matters that much, but let's see. So if we have, if this one is equal to this one, we get 0. We get 1. That's right. Here we go. Uh, uh, uh. Not really what I want to see. Because, let's see here. Definitely gets rid of the square stuff at least. Yes, that's a win. This is not what I want. That's pretty cool, actually. Taking the wrong values somewhere. Would like to avoid this eventually as well. Am I getting the correct result? No, it's still how... No matter what we do, we still get the brightest points around here, around the edge. Which I thought display upwards breakpoint would fix. Wait, doesn't it though? Maybe it does exactly what we want, it's just not shown that good. Let's see. Not shown that good by displays up multiplier, more like displays up amount, but let's try this. We still want to color it. Could be seeing some form of displacement. Oh. I don't like this sometimes working and sometimes not. It sucks. But I think it's when we recompile this shader, our references gets reset, and at startup we send down a lot of data to the shader, and this data gets reset. So maybe sometimes when we start before the shader has recompiled, we don't get the latest data, but so let's see, by changing max distance and breakpoint, what do? We heighten it too much like this. Okay, I get it. But yeah, we still have the highest point at the wrong point, and that fucking sucks. Why is that? If we do this... But then we also heighten everything else. That's too bad. That is too bad. Just smooth this upwards out, it would look way better. Which I thought this one would do. But I'm definitely missing some knowledge about grade 2 equations. Parabolic ones. It might also be that I'm not really paying attention to our x parameter here. But that doesn't really matter. Could exclude totally zeroed out by just checking here. Like checking this value here. But this should make it so that, or actually this, I reckon that's so that our peak is at 0, but yeah, no, that our peak is at display upward breakpoint. Unless we go way outside, but yeah. And our peak should be because let's take a look here. If we just do x2, get roughly this. If we do minus x2, should be getting want to traverse here, whatever. This right. If we would do minus x2 plus c. So if c is up here, we should be getting this, shouldn't we? And that's what we do. But then we also want to offset it on x if we have this curve initially. So we do minus, we might want to do x2. One sec. We do x minus d plus c. Then we will get our peak at d, right? So I don't see anything wrong with the equation right here from the get-go. Then we saturate it here and here. Yeah, if the d is greater than whatever value we get from this one, then we will get something that looks like, and then it will just be cut off. Is that what we're getting? Maybe. Ah, that is true. That is true. Just going to double check that this value is between 0 and 1, which I've done before. So this tells me it's between 0 and 1, but we have this little if statement here first. which might screw things up for us. Should be okay. Should be okay. Then again, why doesn't this one yield the result I want to see? Pretty much want to put this one at 0.5, which should give us the peak at 0.5. I just want to do this as well. Let's do activity data 0. Are we working with, yeah, this one is working with height boundary. The range of this one is quite big compared to what we want, I would say. I just want to try and do a if displays up multipliers equal to roughly equal to 0, then we break. Then I also want to do we want to offset it. I don't know what's visually best, if we offset it by this one or if we don't. And just return this value. Oh yeah, not break, but We do we don't get anything. Breakpoint 0.5. And do we? What the fuck? Okay. So if this could work together with this, it would be amazing. Ooh. Does this one screw it up in this case? Maybe. No. But. What am I missing here? if this one should never be negative. Between 0 and 1, between 0 and 1. So we will get a value between 0 and 1 here. We might... I wonder, since we're not going... This is always going to be between 0 and 1. This one will always be positive, right? We change it like that. But that means that we will always get a play like this. Maybe we don't want this one, but rather just multiply with it. Or am I screwing things up right now? Let's see, 0.5, 0.5. 0 to the power of 2 is 1, so we get this. Or 0.5, 0.5, yeah. 0.25, 0.5. With negative 0.25 to the power of 2. It should be as simple as this, shouldn't it? And max distance 0.1, 2, 3.5. Let's go with 1, why not? And then break point. I want this, but the opposite-ish. Gun. Wonder how that would look. Does this one depend on this? Right. Yeah, that's... It might... Ah, we do 1 minus this one here. Hmm. Max distance 1. And break point. There was a bush patiently waiting on your water shader. Of course, yeah. Hopefully it will be out by summer, but we'll see. But why did this screw up? We had a beautiful result previously, I think. If we could just have inverted it. Makes no sense. Because I reckon it's something like this we want. Isn't it? So if this one were highlighted instead, it would look so good. 1 minus this one doesn't work for some reason. I'm gonna have to double check it. Yo, what's up, Caveman Crafting? Wait, I've seen this on a Japanese game show once. They locked the guy in a room and he only could survive with the things he won from mail in Sweden. Yeah. I've heard about that one as well. Didn't he go insane or something like that? Brutal. Fucking hell, if this black line would be white, if we would just invert these values, it would look pretty damn good, I think. I want more control over the equation, definitely, but I'm having a hard time with these equations. It would look so good, I think. And then, of course, we could change it. This look even better, probably. Math is hard indeed. Hmm. Hmm. Looks okay. But if we do 1 minus whatever value we have here, we're gonna have, it's gonna be offsetted a lot here as well. Here we will probably get some nice smoothing here, but yeah. So my question is, displays upward max distance. Can we? One 0.5. If we just set this 1 to 1, we can take it out of our minds. This is just 1. All we have to play around with is this, and that shouldn't be too complicated. Displays multiply. We read it from the activity data. We do 1 minus whatever we have in activity data. The range for this one is extremely big though, so we might want to sorry about that. Might want to push it down together, because the range here of the height data, this one is actually, we have the white bounding box here. For up here it's 1. If we're down here it's 0. So that range might be a bit too yeah, we might want to take that one into account. But still. Still, doing 1 minus this, like we did here, wouldn't that yield us correct result? Although with some shortcomings, of course. But it should definitely not be the result we saw. I don't think. Or apparently it is. Just not seeing it. So let's take a look at this one, the default visuals we get here. We have a value of upward max distance 0 and breakpoint 0. This one is 0. This one goes between 0 and 1. So we have a very low value here. Pretty much close to 0. We do 1 minus this, of course. If we play around with the values and max distance, let's just put this at 1. But breakpoint. we could just, what am I missing? If we could just get something between this and this, it would be golden. It would be so fucking good. I'm just gonna hack it real quick. We're just gonna calculate both of these things. And then we're gonna multiply them together. Fuck it. That should work. So we take this one, and we multiply it with this one. And then we see what we get. Place multiply, let's just keep that one. Let's place multiplier 2. What was it? Breakpoint we changed, right? So one should be negative, one should be plus. Right. Don't want an R there. And then we do displace up multiplier times displace up multiplier 2. Let's just see what we get from this. Fuck it. Max distance 1. Okay. What am I getting at? We want to do I think we have a lot of fine values here, or high precision. We're in a... So compared to the big span of between 0 and 1, our values are in a very tight span. We want to be delicate how we transform it. Very good. It's extremely good. Yeah, so if we were to be as boring as doing a min in the two, Does it feel like we're only getting one side of the things? Yes. Could it be? Could it be that we want two different values here? Maybe. If we do them the exact same way, let's place up multiplier. They're oh, test A, do we use this one? Definitely feels we can do this in a much cleaner way, but test A. So if we go this maybe, and this is probably, we probably want something like this. It's just that, like, how to get here or how we get here doesn't sit right with me, but this could probably look pretty damn good. Let me just open Notepad and write these in. We can check how it would look with some displacement. What did we have? Minus 0.62 and 1.1, really? Probably wanna, if we bring this one down and this one, I reckon this could be pretty good. It would look way better if we could get rid of those. Whatever this is. Test A3, 4. That's way too big. Okay, let's try. A little bit too high. Derek, I love that I managed to cause you a week of dev time on a suggestion of mine. It's like that sometimes. Yeah, I think it's gonna look real good. It's a good suggestion. Definitely. But why are we getting these higher values? Well, let's try and add back. Did we have minus 0.62 and 1.1? It's too big. We get this artifact as well. So 1. You want to go negative? Okay, this is good to know. If we could bring it down a bit. Still got a very pointy end, but I'm wondering if that is because of... Yeah, if we just do it subtle, just a tiny bit. Well, what we want to do is this. Displays up value, we don't want to do it like this. So we can probably remove this one as well. Do it like this, and then we're gonna take this one times displays upward max distance. Yeah, we're getting a pos. If display upward breakpoint is negative, we're getting a positive value for one of these. that might be screwing us over, I reckon. But let's try this one and see what we get. Let's try these values first. So it's this one, negative 0.62 and test A 1.1 gave pretty good values. But then we also have max distance. I want to see the... Fuck, we get these errors here. Yeah, that sucks. We'll probably get around that. Yeah, it's that we move in negative direction. Yeah, that we get a negative value, but we can fix that. Still, the peak is fucked. Mm-hmm. I think we can fix this pretty easily. But still... You do it like this. I think. Mm. Probably gonna have to rethink it a tiny bit with the initial I'm wondering. I don't think we get the correct shading here, which might make the result look a little bit worse than it is. Probably want a bit more gradient here as well. I wonder if this is the best-ish result we can get. Current approach. Probably smooth it out even more. Okay. I think I want to clean this up a bit. I want to get the shading working, or the normal calculation working with the new values. We don't take those into account right now, which might make shading look a little bit bad. And I'm also thinking about a little bit of a different approach to this problem. I got sent a video by Sebastian Leigh, is that how you pronounce it? From Fabric this morning, or yesterday. Which has some min smoothing between some nice curves that could help us. The only problem being that we would need to alter a few things. And so right now, we pretty much do it like and let's draw snow as a little bit of blue. So if we have the snow here, we pretty much split. So the way we do it right now is that we take the parts of the snow directly affected by the person. That's like one subset. And then we take the snow that is adjacent to snow that is being directly affected by the person, and that's another subset. That's pretty much, yeah, we do it as two subsets, I would reckon. And now with the way we implemented the equation, we actually do it in, we take these two and do them as two subsets as well. Like we're pretty much splitting it up in all of these different parts and then try to blend it in a nice way at the end. I'm not too sure I like that approach. I mean, it works, it gives okayish result. What would be much better is if we could take this whole area, assign it values, of course, or like merge the values in some nice way, and then we do one function on all of that. And that function would look like, so we get this result-ish. Like that would be the end goal, I reckon. And this part right here is what can be seen in the video, which we could utilize. The only problem being that we would need to structure this data and organize it and transform the values, etc., into a range that would make sense with this one right here. So that would be, when it comes to displacing the snow, but then again, we really need to differentiate hard between these two and this one. This one is directly occupied. This one, these two gets filled by its neighbors. I don't know. The end goal would be to utilize this. But I wonder if the road there would be too cumbersome or... Right now with our solution we get something like... What does it look like? Something like this, right? We get peaks. That's problem number one. We get peaks. And problem number two is that these sections, they have too little control, or they don't have any control over this section. Like this one is the primary one, so whatever this one says overrides anything else, which means that we get these nice, or like this corresponds to this section, and then we have this green section. Like this part is unaffected by these parts. So if we could merge them beforehand, do one function on them, we would get rid of, depending on the function, we would get rid of these, but we would most likely get rid of these little fucks. But I would say I probably want to get the shading to work with this new deformation. I don't think it fully does. Like when we calculate the normals, we don't take into account the displacement upwards. So let's see here. Maybe we can restructure the code a bit, make it a bit cleaner. Pretty much what it comes down to as well is to calculate normals, we're going to have to read neighbors. So for all the neighbors of interest, that is. So I guess for this, and this. So for 6 values, I wonder if, yeah, we're gonna have to do, so when we calculate this point, we want to offset this point. We're actually gonna have to read the values, or we're gonna have to reconstruct these 6 points as well to get the normals. To get the correct normals. It's not gonna be easy. okay, if we could, if we want these sections to be a bit more in sync with one another, we could probably, we're gonna have to, I think we're gonna have to work with a 2 parameter function. X being the displacement downwards and Y being the displacement upwards. Have to make this one weigh a little bit more heavy, because so like this area we'll see. Under. It has to be crystal clear what defines this area and this and this. And if we can do this, so what I'm getting at is, so it's pretty much, right now we're pretty much do branching. We do, if we're in this area, do these calculations. If we're in this area, do these calculations. I don't want to do branching, I just want to assume we're in both sections. But I want this one to weigh a bit more. So for instance, fuck, does this make sense? So if we draw the character again, and we have the snow, pretty much what do I want to do? Oh, fuck yeah, this makes sense, and then we can do a smooth min. Look at the video. Like, we calculate one curve for offsetting the snow upwards, so that would probably be something like this. And then we calculate one curve for offsetting the snow downwards. Maybe like this. So then we have 2 curves, each describing the offset. And then we blend them in some nice way. This wouldn't give the best visuals, but something like that maybe. And do blend. I hope. But yeah, we'll get to it. But one thing is for sure, we need to clean up this code a bit. Get the normals working with the displacement upwards. Yep. So what I'm getting at here is inside of this one right here, this is where we read all of the values and calculate all of the positions for the point we're at and its neighbors. And this is what we later use to calculate the normal. So we can see here that we fetch some values here, calculate the normal here, then we displace upwards. We don't have all the information, or displacing upwards pretty much make this one deprecated. Or, yeah, it's not accurate anymore. So pretty much when we do this stuff, like when we collect these and calculate these, that's where we want to whatever positions we have in here should be displaced upwards and should be displaced downwards. So what I want here is float 3, calculate displaced position OS. Float 3, position OS. Or actually, float 2 UV. Yeah, what's up, Scapers? Snow, is that an euphemism for water? Well, we were initially working with water, but to get the displacement on the water working, I thought it would be easier to work with it in its solid form. So we moved to snow, and hopefully when we have that in place, we can move back to the water with way more knowledge. And I've just been dying to do snow for a long time, so yeah. Calculate displaced position, and we just send in a UV, so it's pretty much this one when we're gonna send in, and displace some. We're gonna do a lot of renaming and things like that. Step multiplier. Okay. Actually, one sec. Before we do this, I'm gonna commit this real quick. It's snow in some form. But I want to keep this. I still think this is like one level. Like we have, with this implementation, we have moved one step towards acceptance. We're still not quite right there, but like we moved a whole step, a whole level. So I just want to commit this as it is. So what we're going to do now is we're going to commit this as it is, restructure it a bit, make it a little bit cleaner, easier to work with. Then we can commit that, and then we can get back to the problem at hand. I'll fix the normals. Okay, yeah, let's commit this. It's just the shader. Okay, there we go. So no matter how much we destroy this one now, we still have it at the previous acceptable state. Okay, so that's good to know. Now, let's put this one back here. So pretty much the idea is that we're going to do all the displacement to the vertices in this function, and we're going to have to do it to the neighbors as well, so we get the proper normal function. So for each point, so for each vertex in this mesh, we're going to do at least 2 texture reads and at least 7 calculations. I say calculations, we haven't really decided how thorough they should be yet. If they end up just being calculating 2 equations and then merging them, we should be okay. But we have to remember that this one is run 7 times per vertex. So we don't want this one to be too demanding. And the idea is to merge this, or put this and like this into it, so we can do but also I wonder if we're gonna be a bit I still want to be able to debug it easily, so we want to print out some color values here. So I'm wondering if I want to do a struct, which we eventually can do without, but thinking snow position or snow transform, maybe. Float 3 position OS. Float face down multiplier. Float displays up multiplier. Do we want anything else? I guess we could put normal in here as well, but then we're gonna have it in 2 places, which we're gonna have with this one as well, but let's be let's do it like this, maybe. Calculate snow vertex, we just send it in UV, and we send in float 3 position OS. maybe that's fine. And then we're gonna do snow displace properties. We're gonna have base sample level. Because I think we're, instead of having multiple different sample levels, I'm wondering, maybe not. Base sample level. I want to merge some of these. For instance, if we get so if we want to do the average height displacement value, we want to get that, then we want to get all the adjacent neighbors. So we just want to do it by 3 times 3 kernel. So then it's base sample level plus 1. I will see, we'll see, but I want the base sample level for sure. And we do incremental property HLSL Unity. I don't care. Probably going to represent it by a float in the shade either way. It's just that I want range, but incremental. Like I don't want to be able to... I want range as an int, not a float. So I want to be able to select 0, 1, 2, 3, and not 0.5. But I don't know. If that's possible. Fuck it. Five is probably okay. And we're gonna do 0 by default. So let's see here. Step multiplier 2 to the power of default. Okay. Or base sample level. Then we calculate the UV like this. Step multiplier UV step. And then we have the UV, and everything we want to do here basically is snow vertices. We just want to fill this one up here. Snow vertices. I plus I 1 plus J. Calculate snow vertex. And when we do position OS here, I would probably want this one. So float 3 position OS is equal to pretty much this one, but base data height. Terrain data value range. Yeah, this one is good. So we just recreate the position without float offset, basically. But then again, I wonder. If we want to depend this one on base sample level. Ooh. I don't think we do. No. One sec, however. Base data. Are we gonna need this one here? Maybe it's better to do. To do this one in here as well. But if we do that, we're gonna have to send in I and J as well. But maybe that's not too bad. So we just send in. Fuck, I don't know. One sec. Get terrain base data. I forget, let's do it like this. I don't know if we're gonna reuse this one just yet, so let's do this. Step multiplier, UV, get the base data, reconstruct the position OS, and then we use this. Position OS and UV. Don't care about this one, I think, but we'll clean it up. UV, base data, reconstruct position OS, create snow vertex. And here we're gonna do a lot of reads, but let's see. Let's start with this one, activity data, base sample level. Also do snow vertex dot. Let's do it all at the same time in the end. Maybe, nah. Let's see what we're actually doing here. Yeah, we do this multiple times, so let's skip that. So this is our displacement upward, I reckon. And we do this shit. So average position we don't care about. Here we just set some outputs. That's nice. Displace multiplier, that's upwards. No, downwards, I mean. And then we check if this place is affected. So let's worry about this one first. Rename this one activity height OS. No. World space. Here we just do position OS. Height offset. And then saturate. Can we do this in a better way? So pretty much just take... I don't like that this is world spaces and this is... Is this actually object space? So basically what we do here is we get the height of the terrain in object space for this one, and then we get the height, the activity height. So whatever object we have here, at what height is that one? So let's say that we have this object here, so we get this height. So activity height OS, position OS, and then we do take this value minus this one, so we get this one. If we don't have any object, we get this one where this is the upper bounds. If we have something below, we get this one, so we get a negative value. Constin, you're live. I love your devlogs, bro. Thank you, appreciate it. Hopefully I can put some more out soon. Do you do video editing for fun or perhaps used to work in marketing? I've never actually done any professional work when it comes to video editing. But like as far back as I can remember, I've always enjoyed video editing. I find it extremely fun and intriguing to just create a dope ass video, you know. But I appreciate the kind words. So yes, this one right here corresponds to the distances we have here. Negative ones, we pretty much don't want these, but that's why we do saturate here. But we also do divided by height offset here. And that's pretty much, if we have snow that should be located around, I don't know, here. So then we have this one. So we pretty much take this one divided by this one, we get how much we should displace it. So displace value here is displace multiplier. It's pretty much going to be this one. So I wonder if we want to do snow vertex dot displace down multiplier is equal to this one. Activity height, position height offset. Then we saturate it. And that's about it. We want to saturate this one, but instead we can just do saturate all of this, right? So yes, let's add some structure here as well, so I remember what the hell we're doing here some other day. Calculate down displacement multiplier. I don't know. I'm doing this because this one, we're probably gonna extend this and extend it and extend it and extend it and extend it. It's probably gonna be at least 5 times the lines, maybe. I don't know. It's gonna be way bigger at least. And then I want to do calculate up displacement multiplier here. And pretty much I want to structure it like this. I want to separate the two. What I'm trying to do now is I'm trying to calculate these different functions. So once again, we're going to have one displace down function-ish, and then we're going to have one displacement up function, and then in the end we can hopefully merge these in a very nice way. What's up, Harry boy? How's it going? It's going pretty good, I would say. Slow start, but starting to pick up speed right now. So the idea is that the blue equation is going to be defined here. The purple equation is going to be defined here. And then in the end here, we're going to merge them in some very nice way. Maybe by a min smooth. I'm going to have to check that video again, but probably yes. Then we have displace multiplier. We did this, but we only did it for this one. Height effect threshold. This one is this variable right here we use to differentiate between these sections. So if we look at this one again, this one's job is pretty much just to create a branching for separating this and this section to this section. But this is eventually not what we want to do. So I'm thinking about just removing it. Actually, is that a wise decision? Fuck, once, can you send? No, probably not. It would be beautiful if we could send custom structs between vertex and fragment shader, but no, we're not going to do that. I don't think we're able to do that. Herbo used to watch you a while back, but haven't been on Twitch for a long time. The last thing I saw was you trying to figure out the water. Okay, so that was summer-ish, I reckon. Or end of summer? I don't really remember. But yeah, we have the water in a acceptable state. We can add water to our terrain. It calculates good in most cases. We have some nice visuals for it and stuff like that. But then we moved. Then we came to a point where we wanted to implement the environment affecting the waters, so like creating ripples and edge foam and whatnot. A lot of additional nice visual effects. And to do that, we needed something similar to an, I refer to it as an activity texture at all times. So we moved on to implementing that one. It's pretty much just a texture, a world texture that keeps track of how objects are interacting with the terrain and such. So then we implemented that one, learned a lot of stuff, and now we have started utilizing it, which can be seen here. And I thought that a nice thing to implement to actually utilize it for the first time would be snow, because you have this basic, it turned out it wasn't really basic, but you have this displacement that is more or less dynamic than water displacement. So that's where we're at right now. Long time just been focusing on school and stuff. Oh, that's nice. Finally coming back to self-learning programming, which I'm starting to fall back in love with. Amazing to hear, amazing to hear. Welcome back, welcome back. Half what you talk about makes no sense to me and you seem like a coding god. I wouldn't... I appreciate it. But it might be a tiny bit of exaggeration. Hopefully you will pick up bits and pieces. So yeah, right now we're developing a snow shader, and we're not focusing on the visuals about it so much. And when I say visuals, I mean how light is calculated and snow glitter, specular highlights, whatever. We're focusing on displacing the snow in a nice way. So lower it behind objects or below objects and heightening it around objects and such. I wish I could show you the current state of it, but we're in the middle of a restructure here. So I just have to get this in place and then we can hopefully have something that makes sense. Okay, so this is displace down multiplier. So like melting, more like displacement of the snow. So like when you walk on snow, you push it down, but you also push it in the direction you're moving and to the sides of you. So depends on the snow as well. So like, yeah, when you walk in snow and you push it down, you're probably going to melt it to some amount, but it's more the displacement part we're trying to implement. Yo, what's up, GDs? Okay, so this one is extremely simple right now. I'm okay with that. And we're gonna joint this out. I don't think we need it. We don't need this. We're gonna wait with this one a tiny bit. And then we have this shit show, I would probably call it. And this is our current way of calculating the upwards offset curve. I'm gonna simplify this one a bit. We have this committed, so we have this on the main branch in the repository, so we can do whatever the fuck we want here. We can just revert if we screw it up too much. Although, having said that, it might be better to just comment this out for now. I might want to take a look at it soon. This one is going to be pretty much unchanged. We're going to have to change some variables here, but we're going to wait with this one a bit. So this is just calculating normals after all of the deformation. What we want to do now is this. So I think this is a good thing. So previously when we calculated the displace upwards, we took these sections into account. So we were very careful that we didn't screw with this one and etc, etc. We had a lot of unnecessary constraints on us. So now let's just think about it simple. So if we have our character here, we want to calculate something like this, and I think this is way easier than I think. So like we want to do the opposite of displacing it downwards. We want to displace it upwards, and we want to displace it upwards more if we're at the character here, I reckon. GDs, how does the snow look? Unfortunately, I can't show it right now. I'm doing a little bit of a restructuring. But I will have, so I have my VOD up on YouTube where you can check. If I'm not able to recreate how it looked with this restructuring, you can look on the VOD and see how it looked. But it looked okay. Everybody, I had to go now, but definitely will be back. Alright, have a nice day, have a nice day. And thank you for stopping by, I appreciate it. So this one we have calculated in a very simple way, extremely simple way. So let's actually think about, let's see here. I want to draw the ground. I want to draw the nice little stick figure here, which is our character. And then I want to draw the snow values we have here as well. So the first thing is we want the upwards displacement to cover a bigger area than the downwards displacement. And that's easily fixed. We did it previously. We just sample a different level in the MIPS. Then we get a bigger area. But. So pretty much how can I visualize this? If we sample the 0 level, we might get the activity like this. If we sample one more level, we get the average of this one and all of its neighbors, so we might be getting this one. And it will be the average height of this one, so it will probably be here. I'm thinking we might want to calculate this value in world or in object space, and then we calculate this distance if we're above, so we get this distance, we don't care about it. So we only care about it if we take the snow height minus this activity. Isn't that pretty much what we do? Yeah, we want to do this, but the other way around, right? Because now we want to move in the other direction. And then I wonder, the bigger this gap is, the more we want to displace it upwards. So if we have this one, or do we? I think so. But we have the average also, so yeah. That's a good start, I think. Okay. So let's see here. We're gonna do base sample level and wonder if I want to do it like this. I think we want it to depend on this one, honestly. So, or do we? Averaging sample level? Maybe. Range 0.5. I'm gonna go with 1 by default, so it's gonna be 1 more than this one. I know we already have this one and this one, but I wanna move away from those. So what we do here is, actually, let's do activity data, rain activity data, dynamic. And then we want to do the actual calculation here. So what did we say? Snow vertex displays up multiplier. Yeah, what's up, Diligence? What you working on? Still the snow. Right now we're just restructuring the code a tiny bit, make it a little bit cleaner, and hopefully with the help of Sebastian Leigh, I need to learn how to pronounce his last name, we can merge two curves in the proper way to get this displacement in order. But yeah, we're a few steps ahead, a few steps behind just yet. But okay, so displays up multiplier. This one we want to base on this, so we want to take the snow. So I guess it's position Y plus height offset minus activity height OS. I'm pretty sure. Displace multiplier is equal to, and then we want to saturate it as well. Let's do it like this. Consistency. So position OS dot Y plus height offset minus activity height average OS. Because what we do then is we take this position plus this distance, so we get the position of the snow if we don't have any displacement on it, and then we will get the height of whatever is displacing it. We do minus that one, so we get this distance here. So if we have something up here, we would be getting this, but it would be a negative value. We saturate it, so we don't care about that one. If we get it down here, however, we're gonna get a value. I wonder if we just want to do I pretty much want to get it as a value between 0 and 1, where this is 0 and this is 1. So we can take all of this divided by height offset, right? Much like we do here. So if we have an object below ground, we will get a value that is bigger than this one, but then we saturate it, so it will still just be 1. Something like that. I want to double check how these visually look eventually. But then finally, the idea is that we do snow vertex dot position OS is equal to some calculation that displaces it. So let's do... Actually, let's do it like this so we can properly debug it later on as well. We do snow vertex dot original position original OS, and then we do float include down or displace down. So here we do I want to rename those as well. Height offset. This one I don't like the name of. So snow displace properties, header snow. This one is redundant. Here we do snow height. Range 0 and 1. We're probably never gonna visualize snow with a height of even close to 1, I don't think. We'll probably will land around a maximum of 0.5, so this is in meters. So yeah. Now we start with 0 here. Snow. Snow height. And then let's see. Yeah, we want to clean these up as well. So let's go with snow. Wonder how I want to put this. Snow height. So what I'm wondering now is, do we need to define the maximum amount we can push it down? I don't think so. Because the maximum we can push it down is pretty much 0. Or maybe we don't want it to reach 0. Oh, that's true. So if we have ground here and we have snow here, we might not want the snow to ever get to the same level. Like, we might want to define it so we have a minimum trample down of this. That is good. So that's one thing I'm wondering now, about now, how we want to handle this and define it. But the other one is also, so if this is the red is the ground, blue is the snow. Do we want to define a top? Like, when we displace it upwards, do we want to define this? The maximum amount we can displace it upwards? I think so. And fuck, we want the... Yeah, and we're gonna do it as relative to snow height. I think that's a good idea. So if we have... Or is it? I think so. If we have a tiny bit of snow... So if we have this much snow, we might allow for this much of an offset upwards. But if we have this snow, maybe. We're gonna do... We have displace down multiplier, displace... Let's call it max for now. It's between 0 and 1. Because we're going to multiply this one with this one and the displace down multiplier. And similar for up max multiplier. Hmm. Now we have our flags here as well. If displace include displace down, and if include displace up. This position os.y displace down is equal to minus this one, and then we do displace down max multiplier, no vertex, displace down multiplier, height offset we want to rename as well here. Let's add these. That's not really true. We can do it like this. No height. And then we remove it. Okay, so it's pretty much this. I want to get a better mix between these two eventually. For now, let's do it like this. Snow vertex. Crystal clear. And yes. And then, so when we have displaced, so now we should take both down displacement and up displacement into account when we calculate the normals. That's good. And then we do this, and here we want to change it position OS snow vertex 11 dot position OS. Yo, what's up, Cooler SK? I usually stream around 4 hours, I think, so above 3 hours is not that big of a surprise. But if we go above 4, Okay, I want to do one last thing before we start testing this around. I want to send down some information to the fragment shader so we can properly draw it. It's like we do 2 steps forward, 1 step back, 2 steps forward, 1 step back, but I think that's nice. We're getting some nicer code out of it, at least. But I want to remove all of these, and I want to change the name of these to correspond to this. And we do X chord 3 and 4. Displays up multiplier, displays down multiplier. These I want to set. I want to set them around around here. So we're going to do output dot displays down multiplier. It's equal to Snow vertex. This just so we can render the values, play around with it. We're gonna add an additional flag here, I reckon. Let's see. 2 flags. 3 flags. Include displays down up. I'm gonna have float show displays down. Float show displays up. Float displays. One sec, be right back. Sorry about this. Sorry about that. We have snow show displays down, show displays up, and displays. So basically I want to do show displays. Or displays. If that one is, if it's bigger than, let's go 0.5 or 0.5, then we do this. Otherwise we do get vertex, position inputs. We might have had this one inside here, but whatever. But original. Okay. And then I want something similar here. If show displays down is bigger than 0.5. Turn okay, it's much cleaner, but we have a few. I want to clean it up a bit more. 1, 2, 1, 2. Snow height, shadow amount, ambient, smoothness. Yeah, I think we're good. So when it comes to displacement, it's pretty much all the displacement is going to be handled here, and this is like it's a very crucial point we get this right. So calculate a curve for displacement down, calculate a curve for displacement up, and then we do a nice mix of them. Smooth min, or I don't know, we'll see. But this, when we're doing displacement, this is where we're gonna do it. Everything displacement related. Normals are fixed after the fact, so that's very good. And here we're gonna have everything with polarization of it. Okay, let's see what we have, if we have any compiler errors or something like that. Ooh, the worst one. Never mind. Redefinition of snow text. Valid subscript. Yeah, what we want to do here is session os.y. Okay, do we have anything else? Oh, fuck. Yeah, snow vertex. We have snow vertices. Type mismatch. Really? Sing. So it has to be this one, right? But what is wrong with it? Okay, let's try and do it like this then. And we do this actually. Place down multiplier, and there we go. Why don't we have... Oh, yay. Okay, that's better. Test flags, snow displays, snow, lighting, color. Goes up Milky. Yes, let's try it. Why not? So we don't have any displays upwards now, or rather we don't show it. That looks pretty good. Snow. Okay, let's see here then. We do one here, so we want to show the displays. Let's see, so that one works. We displace it in kind of a weird direction. Fuck. Okay, first thing, and it fails. Yes. Plus times float 3, 0, 1, 0. Oh, did it actually reload? Yeah, but we don't have the activity texture during hot reload, so let's start it. Okay, hopefully we can get the offset to work. That's like the simplest thing. So if we have snow displays 1, we're probably gonna add some default values to these, but snow height, yeah, no, now we go upwards. We have maximum of 1 meter ish. You can see here that we get some nice recolorization here. That's good. But what I want to show is, or what I want to visualize is I want to visualize show displays down. Hmm. Does this one look more precise now? But then, of course, we can do base sample level. Okay, that's pretty cool. And then I want to show, so let's disable that one again. Let's show displays up. This one we would like to have as, fuck me. I would like to show this one inverted as well. I think we want bright values. Maybe, we'll see. But we're pretty much at the same here. So if we do base sample level 0, 0, displays up, and we do this, it's pretty much just the inverted. And that's going to be the case for if we do 1, 1. It's good. I would like to have this one a little bit broader. Yeah, just sampling one MIP more won't give us what we want here. We want to do... Or actually, it might. Fuck yeah, I want to show... I want to be able to visualize the activity texture just as it is as well. I think what's failing here, or the difference here, is actually... this one, I think. One sec. Include displays down 0, 0. Yeah, I'm talking about this one. So when we when we average the activity texture, we're gonna get a lot of points, or we're pretty much gonna average them upwards in object space, which means that if we average them too much, we won't be getting... We're no longer below the snow surface, and if we're not below the snow surface, this one returns 0. So yeah, we definitely need to recalculate this one in a little bit of a different way, but that's okay. We knew that. But let's do... show activity level. Zero. No. We just want to return this as is. To show activity level, if it's greater than 0.5, we read it and we output the height boundary x, so the minimum height value. Yeah. And we need to do input.ub here. So I want to show the difference here. I'm doing this like I've slowed it down a bit, and we do it very thoroughly now because we need to figure out a very smart way to create this curve and this curve. And we want to create them in such a way that they also, when we mix them, we get a good result. But let's see here, snow, and let's show activity level. So here we have level 1, and hopefully so this is averaged once, so we can see that it's a bit lighter than its neighbors, or a bit darker, but it's going to become lighter and lighter the more we put this one up, I think. So when we try to get the area here we want to displace upwards, we pretty much threshold it such that if we get a value above or below ground plus snow, we don't care about it. And that is wrong. That was the wrong assumption from me. We need to check it against something else. Previously we had something like I don't remember what it was called, but yeah. Snow height. 4. Displace 1. Then we can do show displace down 1. No, not that one. Displace down. This one doesn't do anything right now, does it? If we do yeah, show displace down. Include displace down. I would displace down max multiplier. Here we go. But we would get the opposite. Yes, that's what I thought. That's pretty cool. But if we do upwards, displace up max multiplier. Let's wait with that one. Displace up 1 multiplier. Then we get this. Okay, that's good. This is what we want to see. But we want it to be a little bit broader. So we can manage that. Okay, so we're gonna do this. Displace down multiplier. We need to do 1 minus this one. We want to invert it. Highlights or bright part should displace downwards, and dark parts should displace less. But displace up multiplier. We need to recalculate this one. We can't do it like this. This is a bad way to do it. Because basically, let's see if I can visualize this in a nice way that makes sense, that makes me understand it better. It's pretty much just, we're averaging stuff. So if we have a grid like this with 9 values, this one is 1. All of these are 0. The average is going to be below 1, of course, quite far below. Which means that if this value describes our minimum position of the object, if we average it, we have to think a little bit inverted here, because so empty points that hasn't been traversed, they have a value of 1. So if we take this one and we average it, we're gonna get it, it's gonna move up the value here. So we might end up around here. And then if we take this one and compare it as we do now, we try to get this difference. If it's above, we don't care about it. If it's below, we don't care about it. That means that this value is above, so we don't care about it. And that's wrong. So we have to take this averaging into account in some nice, clean way here. And that's the hard part, figuring out how to approach it. Of course. The bottom line is, like, we want to know, we can't just take this value and base it on this, the averaged value alone. We need to know that at some point around here, we actually have some displacement downwards. But then again, we want to displace this one upwards, but this one in of itself doesn't have any displacement downwards. So we need to check its neighbors, right? And that's where we had so previously what we did when we had this somewhat working is we checked this average value, and if it's some distance, if it's within a distance from the snow, then we changed it. So it's pretty much we just drew like this maybe. So when we, instead of comparing it to the snow level, we compared it here. But I wonder if there exists a better way. Or actually, okay, it's like we can visualize it. Maybe that will make some ideas pop up. Actually, I don't think it's... Okay, why did we get this grayish snow now? I don't like the look of that. Maybe. But anyway, show activity level. First of all, show displays up. Is that so? Show displays down. What the fuck? Ah, yeah, snow height. Let's bring this one up a bit. Yes, there we go. I want to get rid of this flickering just a tiny bit. There we go. So this is displays down. Displays up. Displays down. Displays up. Yeah. So activity level. Yeah, I think that's what we want to do. So previous like similar to the previous approach, but a little bit better. So we read this value. Let's see. Yeah. We calculate this value, or we read this value from the texture, and then we compare it to the snow, the ground height plus snow height. But we take the absolute value of that, or we compare it. Yeah, we take the absolute value of that, and if that is within a range, then we mark it. But why are we getting this grayish color? Is it because we don't... Is it because we don't displace? Hmm. Huh? Yeah, I think I know. I think I know. It's because we inverted this one, but we don't inverted these ones. Okay. But let's see here. So include displace here. Calculate up displacement multiplier. We read this one. It's the activity height average in object space. We calculate the distance to the snow. But we don't want to divide, and we don't want to saturate. So position y plus snow height minus activity height average. So we do this one minus whatever we read. So if we have something here, or something here. Yeah, and then we pretty much want to... Yeah, we just want to take the absolute value of that one. I reckon. We do abs of whatever we have. And we also want to do And here we want to introduce an additional property. And it's going to be this one. So we pretty much want to do a inv lerp between 0, our new constant, and this result. I think. What should we call this one? I'm going to call it snow displays, down, up, displays, up, activity, height, threshold. It's 0 by default. So we want to calculate this, we want to do the abs. And then we want to do inverse lerp between 0, inverse lerp 0, 1 actually. Between 0 and this one, and whatever our result here is. Let's try and see what kind of result we get from this one. I think it's going to be extremely similar to what we had previously. But I hope it's a more useful value for us. Need to offset this a bit as well. So snow height 0.5, and then we do show displays up. And right now we have 0 at displays up active threshold. Show. If we do it too much, we're going to start seeing it all over the place. That's not good, but this is okay. And then we can no, I'm definitely not seeing what I wanted to see here. Why are we getting this result? It's weird. I think this one is better if we compare it to, or actually is it exactly the same? Okay, it is. Displays up activity height threshold. What we're working with. It's pretty much something like this I want to see, but more averaged. Or less saturated. What am I doing wrong here? Inverse lerp 0. You do a simple or a simpler thresholding. Just checking. Like if we just want to ignore the non-traversed points. But we need to keep in mind we want this to work with flying shit, maybe. Yo, what's up, E-Dragon? It's going pretty good. We have restructured the whole thing, and we're just trying to improve upon it right now. It's a hard thing because we want to differentiate we need to keep this in mind. We want to differentiate between these two. For this one, we probably don't want to do. And if we have snow here, we want to differentiate between this and this. Like if we take the average here, average of the height from the ground here for anything that occupied it is probably going to be higher for this one as opposed to this one, and that screws us a tiny bit. One sec. But we need to remember that we actually have more data at our disposal. The question is, do I want to start? Yeah, we probably want to work with velocity direction either way. Oof. It's also, we have added an additional constraint to whatever we do here. Previously, we could actually use the position of the neighbors when we were calculating the so previously we could use the neighbor values to recalculate stuff, the intermediate neighbor values. But we don't want to do that anymore because it's very important that we do all the offsetting here, so here, and as soon as we leave this kernel, we don't want to change any position anymore because that's when we calculate our normal, and it's extremely important that our normal has access to all the height data and stuff, or the correct height positions, otherwise we get the wrong normals. But we do have access to. The fuck does that matter? It's pretty much like this. If we look at it from above, and we have our object here, and it has moved something like this. And then we average the height, so we get, in a perfect world, we would be getting, it's going to become pixelated, but we get something like this. And this. And the more you go like the further away we move from this white area, the more averaged value we're going to get on our height value. And in this case, when it's untouched around, that's going to mean that we get a higher value. So the further out we go, we can paint it like this maybe. What do we have? White. If the minimum height value for the white one ends up here, or the green one, the average is going to be here. And for the purple one, the average is going to be here pretty much. Wonder if we want to do... I just want to see what kind of result we get from this. If we change displays up activity height threshold, change this one to a vector. The 2 here. So then we lerp between the X and the Y here. Let's just see what kind of result we get from that. It won't fix the flying stuff, I don't think, which is unfortunate. Maybe can handle that in another way. So if we take a look at our show displays up, do one here. But if we go, we don't want to go too high. Care about 1 meter maybe. Are we way above 1 meter here? That doesn't feel right. Maybe we are. What do we have on environment? 5 meters. Yeah, we definitely do. So for this one right here, we're doing a kernel of... Yeah, the majority is at 5. 3. Really? But if we were to utilize, this is the minimum data we have. What if we were to utilize this one? The maximum. If we average this one, gonna get closer to the ground, and then we average the minimum height and we get further away from the ground. If they are within a certain span, we might be able to do stuff. And that would exclude... Let's see. What would happen here? We have this one, or this one. If we average, this one moves up, this one moves down. Here we have, what do we have here? We have maximum, minimum. Maximum is never gonna get down to the ground. So maybe, I don't know if I like this, but if we introduce the maximum height as well, and we do stuff with that one. Let's see. I wanna add a simpler way to do this. I wanna add it. Show activity level. Am I doing? Show activity height min level. Do it like this. Maybe. And then also we want to change it down here. Let's see what kind of result we get from this. I wonder if I'm doing a mistake introducing max height here. Maybe not. 0.01. And we do so show activity min level, we get this, it fades out more and more and more. We're gonna get the same with height, but it's gonna fade out in the correct direction. This is way better actually. But we can probably not use just this one. I want to see here. Can we introduce prefabs? Didn't I have MISC? Okay, cube object entity sphere. Where do we have it? Really? Use gravity, put it at 0. Where do we have it here? Can we paint the texture with this if we don't pause? Yeah, we can. Where do we have the sphere now? Here we have it. Oh, is it still falling? Make entity. Why does it keep falling through my floor? That's not good. Yeah, because we still have velocity for it. Can we do... let's do the test again, but we add it from the start then. Entity, sphere. 0, 0, 0, 2. No gravity. I just want to test what happens if we have this one way above ground. So 1. And we want to show this one, show activity level 1, max. Now we take our sphere. Where do we have it? is kinematic 0, 0, 0, 10. So if it's kinematic, we don't draw it on here. But if I disable kinematic now, what do we have? Okay. And then we do snow. Okay, we already have snow. Entity sphere. Let's bring it over here. Yeah, so it's extremely bright. But if we do, yeah, this is when we want to compare. So if we do min and max here, I wonder when we take the average, we want to compare these two. If we're within some range, then we know that the object occupying affects this. Yeah, we're going to get some issues when we have two different objects occupying different heights at the same point. But I reckon that won't be such a big problem. This is way... let's experiment, see if we can find a middle ground that's acceptable for this. Will this work? Maybe. Okay, let's do it. I want to do... And then what I want to do is... I want to do some weird calculations here. So let's displace up multiplier. Okay, instead of this, what we're going to do is... give the average data, we have it here. Let's do... displays up multiplier is equal to abs activity average data height boundary dot y minus activity average data height boundary dot x. Then we get the difference between these, and I want to do is equal to it's between 0 and 1. So let's do inverse slurp 0, 1. We do 0 and in max threshold. I want to see what kind of result we get with this. Average data. And this is our displays up multiplier. Yeah. But do 1 minus. So the closer they are, the brighter it will be. I would like to be able to do this without introducing height min. Oh, that's not the one. So what do we want to visualize? We want to visualize displays up. This one. And if we do the threshold, if we set the threshold to 1, yeah, we should be seeing this. That's good. I wonder if we do 1.1, 3, 4, 5. Oh, yeah. Worst case scenario, we get 1 minus minus 1. Oh. Worst case scenario should be, or is it 5? Now this is worst case 1, or the most we're gonna get. We have 0 here because, yeah, the difference is a lot. Okay, that's good. And what if we did, so if we play around with this one, okay. Huh. Okay, so what if we make this a bit larger? we get above 1, yeah, we're gonna start introducing these, that's true. But this looks pretty good. Only problem being, of course, okay. This actually looks very good. But what happens if we introduce our entity sphere? Yeah, this is not what we want to see. Minimum, maximum. Are they moving so far apart? Uh, oh. It's too bad. I want to try that again. Real annoying when the properties of the material gets reset during a change. Thought it was only during when it was recompiling, but I might be mistaken. So let's double check this again. Let's pause. .01. And then we go show displays up. 1. Make this a little bit bigger. Okay, that's pretty damn good though. And okay, so now it's only 0.27. But yeah, 0.5 entity sphere. I don't think... Thinking about this the correct way. Minimum, maximum. You should be getting... They should interchange pretty much. That's not what I'm seeing here. We lose this one. We lose this one way before we lose this one. That's interesting though. Did I mess up that badly? Show activity min. Okay, maybe, so this min, does this make sense? Round, object, object. Minimum here, the minimum here. We'll do minimum here, minimum here. Yeah, they have the same type. When we average them, we move them towards each other. And we probably want to take the average height of them and compare this to the ground, maybe. Pretty much calculating a middle point. Because these two are going to have the same distance between min and max. Eventually. But the whole idea is that when we average them, the minimum height average is going to go up in the air, and the average height max value is going to go down towards the ground. So it's pretty much we just average the min, but we average this one as well. We get that one for free, but it's just a question of, do I really want to keep track of max height in my data? Maybe we can find a better value. But anyway, if we average it, then we could probably take... We take the height of this, the min and max averaged, and then we compare this one to the snow height. That would get rid of this one at least. That's for sure. Or actually, would it? Bottom line is this one would have an average that is way above the ground, way above this one at least. But then it depends on when we do this comparison, or comparison to the snow. Mm. Yes, this is the route we want to take. And then I wonder if this average value here, if this is the one we want to put in this function. Activity height average OS. We can try and do like this time around. Let's exit this. Displace multiply, instead of doing abs here, we take this one. Plus this one divided by 2. Yeah. And then, can we still go with this one? Maybe we can. No. We maybe we want to take this. So we take position OS plus snow height minus this one, but this one isn't. Take this one as well, do we? Yeah, I think so. So we average them and we calculate this one, or make it into object space instead of normalized. And we inverse lerp. So yeah, if the distance to the snow is between these two, then we do it. Let's try it. To 1. Jesus, is that some good? It's between 0.5 and actually 0 and 0.5. That might make sense. 1. What happens if we go up here and then it gets removed? Let's get thinner. Should be getting this. Definitely not. This result makes sense. So here we should have 1 and 0, 1 for min, 0 for max. The difference between those are 1. We get 0 plus 1 divided by 2, that's 0.5. Then we do a lerp, so we get terrain mouse, we get 2.5 here. So this one is 2.5. Oh. Okay, this is... $2.5. One sec, let me just check what we had previously. I'm just gonna make sure that... I think the previous solution, or I thought the previous solution used that we altered the height outside of the kernel. I just want to make sure that's the case. So let's see here. Kernel, and then we do some shit here. Yeah, this is... Can we do without this one? Displays affected. We just use this one as is. Why are we getting so much brighter values this time around? Mm. Sec. It's this one that does some heavy lifting. Displays value. I see, I see. That's also one problem we had with this solution was that it didn't really work that well forward. I don't think we can use this anymore. We could use it, but I want to improve it. Min and max should work. It really should. Averaging it, however, doesn't give the result we want. Or the way we do it right now doesn't. But so I wonder. We could do it like this. Let's see. We might do it if we just add a filter to... Can we do it? We could probably calculate if I'm trying to figure out if there's a way we get the value for these 9 pixels averaged. If we can, given that value, if we can somehow deduce how many of these that are unoccupied. The problem we have is that when we average with a lot of 1 values, we get a very high value, which we don't want. And again, get a pretty nice area with this one, although I wonder. only this one gave us such a good number. Oh, and also, of course, the fact that we did this here. That is true. This makes me want to try. Let's do. Maybe we can do it here. Yeah. Show activity min level. Disable this one. Yeah, we can definitely use this, but the problem is, yeah, of course, if we take the entity sphere, we have this one here, unpause, and we bring it here. But it's way lighter, so the question is, like, how do we differentiate between this and this? That's all we want to do. But yeah, then again, that's not the only thing we can rely on. When this one flies over here, it's gonna make, isn't it? Yeah, it makes it darker. Yeah, we have to differentiate between something that is actually close to the snow and something that is way further away. I thought the minimum and maximum height would or could fix this. If we go the averaging route or the MIP route, which we want to, maybe there's no way around this specific case. Oh, yeah, yes. Okay. Is this the case? Yeah, maybe. Yeah, we store the values, we never replace them. We never replace them unless we have something that is smaller. I.e. if, let's see here. Yeah, let's do min. If we fly this one here, and then we go up and fly it back. We don't get a difference in values here. This was solvable by just using the minimum height. That would be the best. Like we have snow, we don't want to trample it unless we trample it more. Or we might want to differentiate a tiny bit, but whatever. Yeah, the only problem is, like, depending on how much we average this one at 3... Oh, not here, but... The problem is when this, something extremely close to the ground, it has the same, roughly the same value as this, something far above the ground. So this and this. We need to differentiate between this and this. Best case, if we could do it with just the minimum height. It's super important that we average it because we want it to grow in the XZ. But it's also extremely important that we don't do it outside of here. I.e. Best case scenario, we do it in here. We could probably do a second for loop right after this one, but I don't know. I don't really know how to go about this one. Feeling a little bit out of ideas. Two nested for loops after each other, then we could probably do a little bit more. But I don't know if that... Like if we could do some comparisons with... Or, I mean, this could also be solved by this could also be solved by differentiate by untouched values and touched values, definitely. So instead of having the default in the activity texture for minimum height be 1 or max, we can have it at 0. And when we write to it, we never write because then we can differentiate between untouched stuff and touched stuff. But that could probably help. We can experiment it with a bit. I'm just trying to figure out how it would affect the averaging when we do MIPS. I don't think it would be any different, honestly. The bigger problem is that when we average min height, we move up. We average max height, we move down. I still think there's something to this one. It's a question of how much do we move up, how much do we move down. But. Or this makes me wonder if we want to if it might be a better option to, or if we need to change some things around in the activity texture, render some additional data, manage to do this in a good way. Like if we could render if we could replace maximum height with our own I'm wondering if we should move away from doing it with MIPS and doing it with additional data. That doesn't feel too good. Or if, and now we're moving on to experimental territory. What if we were to render one of these ourselves? We get a better result? I don't know. But we don't want to do a double render here, that's for sure. Yo, what's up? Ian, sorry about that. Keep it up, mate. Keep at it, mate. Enjoy your day. You too, you too. Yeah, I'm gonna have to ponder this one, I think. I mean, like, I have a few ideas how we could solve it, but all of them include a lot of extra stuff. And I don't want to take that performance hit, I don't think. Like, if I can avoid it, I want to avoid it, right? We have But I can't sleep on this one. What do we have here? Hmm. Doing the comparison. Yeah, the way we do the comparison right now, like, increasing the base sample would like to see. A little bit more averaging, I suppose. Maybe this is good. Although not not a fan of these. This tells me that something is a little bit amiss. Base sample level. Let's take a look at this. Yeah, this step multiplier. We don't want to do this here. I think we want to do this one here. I wonder if this one has screwed it up for us. Would be nice. I don't think so. Yeah, I think it did a little bit, but I'm not sure it's... Way better shading now, at least. Yo, what's up, Wormius? would say we get way better shading now. That's good. And that snow looks like it would require some resources. Yeah, it definitely would. Or it definitely does. But it's not too bad, and we have some optimizations to do when we're happy with the visuals. It actually looks better at 1, I would say. One more thing, I might have fucked up a tiny bit. We're gonna explore it soon. I wonder... I wonder if... let's show... Let's just try and do... I'm just gonna do it like this for now. Displays up multiplier. So this is solution 1. Solution 1, solution 2. Let's just do... Activity average data, height boundary, dot x. I just want to do this time around. Display 1. I would love it if we could just utilize this one. We have the fact that we have a... have it here. But there should really be a noticeable difference between this one and this. Maybe we can use this actually. We're just gonna have to be real careful with the values and how we utilize it. But if this one gets down to here, we can see that we get... Maybe that's okay.
It pretty much looks like this is even darker than this, right? So yeah, we would be getting... We would displace the snow upwards here as well, and we don't want to do that. Yeah, the averaging of this one is even darker than this one, so yeah. But. What a hard problem to solve. At least with the constraints added to it. Then again, we could also... Yeah, that won't work with dynamic velocity, but if we used... If we would save the velocity... Like if we have the velocity, strength and direction, then we could read those values, right? Would that look? So if we have the velocity, but that would be, we don't keep adding it if we slow down. We always store. We don't want to do that either. But if we have the velocity direction, what you could do is you could check in the direction of it and read that value and offset it based on that value. That would look pretty cool, I think. Yeah, this might be one direction we might be exploring. Definitely prefer just utilizing this one. But some changes are gonna have to be made to it. I mean, we could limit it a bit more, i.e. we don't save the value of this one because it's so far away from the ground that we don't care about it. But that's also a direction I haven't... Would like to avoid that one as well, I think. Pretty much gonna have to write all of these down and compare them, pros and cons. But like, because in that case, this one would not read, or this one would not write its height data to the activity texture, because it's not actually affecting it. But that limits some other stuff we can do, or possible stuff in the future. But that would definitely get rid of this line, which we don't care about. And then that means that we can utilize this one like we did, but we just utilize it in a little bit of a nicer way. And we're golden. But. Yeah, I'm gonna have to think about this. Hopefully I have a clear way forward or something we can experiment with tomorrow, because I gotta run now. If I don't, we're gonna do some other stuff with the snow. Maybe look into tessellation, quad flipping, whatnot. We have a lot of options. But still, I think good progress today. At least in the ideas department. But yeah, so thank you so much for watching, everybody. I appreciate it, and have a great rest of the day. Peace.